everyone. Welcome to today's class. That is lesson number 6 of module number 2. In today's class, we will be learning about factors affecting compaction and effects of compaction on soil. Okay, we will start now. Before we start today's class, we will revise briefly about what was done in the previous class. Uh, in the We are dealing with compaction of soils. So in the last class, we discussed about compaction test. In compaction test, there are two types of compaction test: standard compaction test and modified compaction test, or standard Proctor test and modified Proctor test. And the difference between both the tests is uh, modified Proctor test is conducted when heavy loads are involved, and standard Proctor tests are conducted when the loads that are expected on the soil are in the lower range, and also the compaction energy that is applied in the modified Proctor test is more compared to that in standard Proctor test. In today's class, we'll learn about what are the factors that are affecting the compaction of soil. There are many factors that affect the compaction of soil. The first factor is water content. I had explained in the first class of the compaction what is the relation between water content and dry density. Now, you can see in this graph, x-axis is water content, okay, and y-axis is dry density. Now, as the water content increases, the dry density increases up to a certain point, and after that point, uh, even if you increase the water content, the dry density is going to decrease. Now, this point is maximum point, and the dry density corresponding to this point is maximum dry density, and water content corresponding to this point is called optimum moisture content. And uh, left side of this point is called as dry side of the OMC. Left side of the maximum point is called dry side of the OMC, and right side of this point is called as wet side of OMC. Please remember this. If the water content is less than OMC, then it is called dry side of OMC. If water content is more than OMC, it is called wet side of OMC. We'll be using these terms many times in this class. Okay. So water content less than OMC, dry side; water content more than OMC, left side. Uh, so water content increases the compaction only up to certain point, and after that point, the density is going to decrease with the increase in water content. Now, I have told you initially the density increases because the water provides a lubricating effect on the soil particles and it densifies the arrangement of soil particles. Now, after reaching the maximum point, uh, additional uh, water, the extra water that is added, it will separate the particles. Okay. This separation of particles will lead to increase in the volume, and this increase in volume will decrease the density. So this is the effect of water content on density. The next is amount of compaction. Okay. Um, Now we had seen two tests, that is standard Proctor test and modified Proctor test. Okay. In standard Proctor test, the maximum dry density and optimum maximum dry density is lower than that of modified Proctor test, and OMC is more than that of modified Proctor test. For example, I'll just show you the graph of SPT and MPT conducted on the same soil. Okay. So this is my y-axis and this is x-axis. Y-axis is dry density or dry unit weight, and x-axis is water content. Now, let's say we conduct standard Proctor test, and I get this compaction curve. I conduct standard Proctor test in my laboratory, and I get this compaction curve. And on the same soil, let's say I conduct modified Proctor test. Same soil, I am conducting modified Proctor test, and let's say I get this compaction curve. So if you compare both the curves, the maximum dry density of modified Proctor test is more than that of maximum dry density of standard Proctor test. So this is my maximum dry density of standard Proctor test. And this is my dry density of maximum dry density of modified Proctor test. So maximum dry density obtained from modified Proctor test will always be greater than maximum dry density obtained from standard Proctor test. And also if you compare optimum moisture content, this is my optimum moisture content of standard Proctor test. OMC of standard Proctor test, and this is the OMC of modified Proctor test. So you can observe optimum moisture content of modified Proctor test is always less than optimum moisture content of standard Proctor test. So please remember, more the compaction energy, more will be, and lesser will be optimum moisture content. Okay, any doubts? The second factor that is affecting the compaction is amount of compaction, that is energy of compaction. If the amount of compaction is more, maximum dry density will be more and optimum moisture content will be less. More more amount of energy leads to more maximum dry density and lesser op optimum moisture content. So this is the second factor affecting the compaction. So you can see here also in this curve, higher the compaction energy, more will be maximum dry density and lesser will be optimum moisture content. But however, there is no linear relationship between compaction effort and maximum dry density.
Sir, you muted.
Huh? Okay, can you hear me now?
Yes, sir.
Since when was I mute? Did you understand this second factor, amount of compaction energy? Anyone? Okay, you can hear me now, right? I'll just quickly explain this again. Uh, this blue compaction curve represents compaction curve of uh, modified Proctor test, and this red curve it represents compaction curve of standard Proctor test conducted on same soil. Now, this is my maximum dry density of standard Proctor test, and this is the maximum. This blue line is the maximum dry density of modified Proctor test. We can observe here the dry density obtained from modified Proctor test is more than dry density, maximum dry density obtained from standard Proctor test. So more the compaction energy, more will be your maximum dry density. And also you can observe the optimum moisture content. Optimum moisture content of modified Proctor test is less than optimum moisture content of standard Proctor test. So more the compaction energy, lesser will be your optimum moisture content. Understood? Okay. So more the compaction energy, more will be maximum dry density, and less will be uh, lesser will be the value of optimum moisture content. Now let us move to the next factor that is affecting the compaction. That is method of compaction. Now there are many methods by which a soil can be compacted. First is by impact. Um, an example of compaction by impact is when you're tamping the soil using a flat plate. Usually, when a small amount of soil is in, small volume of soil is involved, we use tamping plates. Using the tamping plates, we compact the soil. Mm. by kneading is like I showed you the video where they were conducting a standard Proctor test in laboratory. Kneading means mixing the soil with water and then compacting. The next type of compaction is rolling. We have seen this, the soil being compacted by road rollers. Also, bitumen or asphalt is compacted using road rollers. These are the different types of compaction that can be applied. And also, soil can be compacted using vibration. If that particular machine is vibrating, then that vibration leads to densification of materials. You will see in the next class how the soil is compacted by vibration. But just remember these methods: compaction by impact, compaction by kneading. Kneading is mixing and then compacting, and compaction by rolling. We are using road rollers, and also the cricket pitch is compacted using a small roller. That is example of compaction by rolling, and also vibration. So the method by which we are compacting the soil also affects the compaction. If you are using machinery that vibrates, okay, that will provide much better compaction compared to impact, uh, or just simply rolling. So the method or the method by which the soil is compacting also affects the compaction. It also affects the density achieved in the compaction. The next factor that is affecting the compaction is type of soil. Now, I'll explain this curve first. We already know what is the classification of soil. Soils are classified into coarse grained soil and fine grained soil. And in coarse grained soil, you have gravel and sand. In fine grained soil, you have clay and silt. So, when this given soil is coarse grained soil, and if it is a well graded coarse grained soil, the soil will attain much higher density and lower optimum moisture content compared to the fine grained soils. That is because fine grained soil, the specific surface area is more, hence, fine grained soils require more water for lubrication. So, please remember, uh, when you compact a soil, if that soil is coarse grained soil, it will achieve greater density compared to that of fine grained soil. And also, the optimum moisture content of coarse grained soil is lower than that of fine grained soil. Fine grained soil requires more water because the soil particles, the fine grained soil particles, specific surface area is more, so its surface activity will be more. Hence, it requires more water for lubrication of soil particles, and that's why the optimum moisture content of fine grained soils are more compared to optimum moisture content of coarse grained soil. So, In this graph, you can see GW is well graded gravel. It has the highest maximum dry density and lowest optimum moisture content. And next, well graded sand. Its maximum dry density is slightly less than uh, its maximum dry density is slightly less than gravel. Then comes silt, and then uh, CL means low compressibility clay, and CH is highly compressible clay. So highly compressible clays are very difficult to work with, and hence the maximum dry density achieved when you compact that type of soil is less, and also you require more density to achieve even that maximum dry density. So please remember, coarse grained soil, more maximum dry density, less optimum moisture content. Fine grained soil, especially clay, highly compressible clay, has lesser value of maximum dry density and more value of optimum moisture content. Um, Also, for clay, this is my, if you are compacting a clay, let's say you are conducting a compaction test on fat clay, pure clay. Fat clays which swells and shrinks too much. So if you are conducting a compaction test on fat clay, this is the curve you will obtain for, this is the compaction curve you will obtain for flat curve. Usually the compaction curve is, it starts here. Okay, if this is my, if this is any normal soil, let's say any coarse grained soil, this is the compaction curve that is obtained. If let's say I have, I'm conducting compaction test on fat clay. So for fat clay, I'll get this compaction curve. So this is for fat clay. Okay, why this? So for a normal soil, as you start increasing water content, the density increases. But in case of fat clay, when you initially increase the water content, the density decreases. So this initial decrease in the density is because if you add if you add water to a fat clay sample, dry clay, initially that clay sample is going to swell. So here there is swelling of clay. What happens when the soil is swelling? The volume will increase. So when there is swelling of clay, when soil swells, volume of the soil will increase. Density is mass divided by volume. So when volume increases, density is going to decrease. So because of this initial swelling of clay, the density is decreasing, and then as you go on adding the water, the density is going to increase. So this is the nature of compaction curve for fat clay. Okay, next we have one more type. I'll explain the compaction curve for sand. For sand also, you will get this type of curve. Okay. This is for sand. Here also, initially when you add water, okay, the dry density is going to decrease, and after some point on further addition of water, the dry density is going to increase. Now here, this decrease is because of bulking. All of you know what is bulking of sand. We have done this experiment in BMT lab. So this initial decrease in the density is because of bulking of sand. So anyone who can tell me what is bulking of sand? Anyone? What is bulking of sand? We have done this experiment in BMT lab, and you have learnt about this in your BMCT subject. What is bulking of sand? Okay, anyone? Okay, bulking of sand. The name itself says bulking. In bulking of sand, the volume of sand is going to increase. The volume of sand, okay, the volume of sand increases. Okay, Omkar says absorption of water. It is not absorption of water, it is adsorption of water. It is not absorption, it is adsorption. There is a lot of difference between adsorption and absorption. Okay, bulking of sand happens because of adsorption of water. ADSORPTION, adsorption. In adsorption of water, the water forms a thin film around soil particles. Okay, if this is my soil particle, if this is my soil particle, okay, in bulking of sand, when initially you add water, that water will form a thin film around the soil particle, and this thin film of soil particle, okay, it increases or it causes repulsion forces between two particles, and because of this the particles get separated. Okay. This thin layer of water that surrounds each particle will cause repulsion between two particles, and because of this repulsion there is separation of particles, and because of this separation volume is going to increase, and because volume increases density will decrease. Clear? Now do you understand what is adsorption, sorry, bulking of sand? When you initially add water, okay, when you add water to the sand, that water will form a thin layer around the soil particle, and this thin layer of water will cause repulsion between two soil particles. And because of this repulsion, or because of this separation, the volume increases, and this increase in volume will lead to decrease in or reduction in density, and this is that part of the curve. Initially when you add water, bulking of sand occurs, and because of this bulking there is decrease in the density, And further, if you go on adding the water, the density is going to increase till it reaches maximum dry density, and further it is going to decrease. So this is the compaction of sand. So these are some of the factors that are affecting compaction. The last factor that is affecting the compaction is admixtures. Okay, usually when we are working with clays, especially highly compressible clays, okay, they do not get compacted easily, or they do not get compacted to higher density that we desire. So what we do, we add stabilizing agents. It may be cement or it may be lime. Cement or lime are most commonly used stabilizers. So if you add these admixtures, addition of this admixture will lead to better compaction. So you will get more maximum dry density or higher maximum dry density values and lesser optimum moisture content values. So when you add, okay, when you are adding admixtures, okay, it reduces the compaction effort and it increases the maximum dry density that is achieved, and also it decreases the optimum moisture content. So these are the factors that are affecting the compaction. The first one is, I'll just revise, water content. So you already know what is the relation between water content and dry density. The second is amount of compaction. More amount of compaction, higher value of dry density and lesser value of optimum moisture content. Next is method of compaction. Okay, whether you're just tapping or whether you are using vibration. Okay, if you are using vibration, more density will be achieved. If you are just rolling the soil, lesser dry density will be achieved compared to vibration. So the method by which the soil is compacted also affects a lot. Next is type of soil. A coarse grained soil achieve higher maximum dry density compared to fine grained soils. Next, if you are adding admixtures, then it is going to help the soil achieve higher values of maximum dry density and lower values of optimum moisture content. So these are the factors affecting compaction. Any doubts? Any doubts in the factors affecting compaction? Shall I move to the next topic? Okay. The next topic is effects of compaction. That is, when you compact the soil, what is its effect on the soil? So, when you compact the soil, what happens to density? Anyone? When you compact the soil, what happens to density? Akash,
Yes, sir.
what happens to the density of soil when you compact the soil?
Reduce. Increase.
When you compact the soil, the density will increase or decrease.
Increase.
Akash,
Decrease.
how density will decrease? When you compact cricket pitch, okay, the density of soil will increase or decrease. Akash,
Yes, sir.
ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗ್ತದೋ ಕಡಿಮೆ ಆಗ್ತದೋ? When you compact the soil, density will increase. We are compacting the soil to increase its density. So after compaction, the density of soil will increase. Next, shear strength. After compaction, the shear strength will increase. Obviously, the shear strength of the soil will increase. Now, the shear strength, especially when you're compacting clay soils, okay, the shear strength of the compacted clays, okay, it depends upon the dry density, the water content, soil structure, method of compaction, and type of soil. You can see this graph. I told you you have to remember the terms dry side and wet side. Dry side meaning the water content is less than optimum moisture content. Wet side means water content is more than optimum moisture content. So if you take a soil, dry side of the optimum moisture content, and if you plot a graph between shear stress and normal stress, its shear, it achieves higher shear strength, okay, compared to the soils which are compacted on the wet side. So please remember, soils compacted dry of optimum. Soils which are compacted on the dry side of the optimum, the shear strength is greater than that of soils compacted on the wet side of the optimum. When I say the soil is compacted dry side of the optimum, that means we are using water content less than optimum moisture content. If the optimum moisture content is 15%, in the field we are using 14% moisture content to compact the soil. So we are compacting the soil on the dry side of the optimum. When I say I am compacting the soil on the wet side of the optimum, that means let's say the optimum moisture content is 15%, but in the field I'm compacting the soil using 17% water content, which is more than 15%. So a soil compacted dry side of the optimum will have higher strength compared to the soil compacting wet side of the optimum. So after compaction, the shear strength is going to increase, especially if you are compacting the soil on the dry side of the optimum. Next is effect of compaction on permeability. Okay, when you are compacting the soil, what you are doing is you are eliminating the air voids. So you are decreasing the void space. So if you are decreasing the void space, you are decreasing the permeability. Permeability is nothing but seepage of water through the soil. So if you are decreasing the void space, lesser amount of water will seep through the soil, or lesser amount of water will flow through soil. Permeability is flow of water through soil. So when you are compacting the soil, you are removing the voids, air voids. So void space is going to decrease. When void space decreases, lesser amount of water will flow through those voids. So after compaction, the permeability is going to decrease. Please remember this, after compaction, the permeability is going to decrease. Next, influence on bearing capacity. Bearing capacity is how much the soil can, how much load the soil can bear without getting failed. Okay, that is in simple words, that is called bearing capacity of soil. So when you are compacting the soil, you are increasing its density. So if you increase its density, then bearing capacity will increase. So after compaction, the bearing capacity of soil increases because density of soil is increasing. Next, influence of compaction on settlement. Now, the compaction, uh, it increases the density and it decreases the voids ratio. It decreases the voids. So if there are less number of voids, there will be less settlement. So after compaction, the soil is going to settle less compared to the soils which are not compacted. So after compaction, the settlement is going to reduce. Next is compressibility. Okay. Now here, if you take a saturated sample of clay, which is compacted wet side of the optimum. Okay. Now the soil which are compacted wet side of the optimum are more compressible than that compared to soils which are compacted dry side of the optimum. So please remember this: soil compacted wet side of optimum shows more compressibility than dry side of optimum. Okay, when low pressure is applied. Even when high pressure is applied, soils which are compacted wet of optimum are more compressible than soils compacted dry side of the optimum. That is because okay, the soils which are on the wet side of the optimum, okay, they have uh, the orientation of those particles are parallel. Okay, you can see here the orientation of particles are parallel to each other. Okay, if you compress those type of particles, then uh, those particles which are parallel to each other get compressed more easily. Okay, the arrangement of soil particles which are on the dry side, now they are flocculated arrangement. Okay, they do not get compressed easily. I told you when I was explaining soil structure. Okay, there are two types of structure. One is flocculated. Okay, uh, this is flocculated arrangement. The particles, they are making edge to edge contact. Okay, this is flocculated structure. And in dispersed structure, the soil particles are parallel to each other. So this type of soil structure is on wet side of optimum. And this is dry side of optimum. Flocculated structures are present in the dry side of optimum. Okay. So soil having dispersed structure can be easily compressed compared to soils having flocculated structure. That's why soil has more compressibility when it is on the wet side of optimum. The next, influence of compaction on soil structure. Okay, on the dry side of optimum, the structure is flocculated, and on the wet side of optimum, the structure is dispersed. When you compact fine grained soils or clay soils, and when the arrangement is in a flocculated manner, okay, the particles repel and density is less. There is edge to edge contact, so the particles they repel with each other, hence the density is less. When you add water, those edge to edge particles they get lubricated and they get arranged in dispersed structure. Now when you are compacting coarse grained soil, okay, the coarse grained soil they have single grained structure and they maintain single grained structure before and after the compaction. The next is influence of compaction on pore pressure. Now the clayey soil which is compacted dry of optimum tends to develop substantially lower pore pressure compared to the wet side of optimum. So the soil which is on the dry side of optimum will have lower pore pressure compared to the soil which is on the wet side of optimum at low strains as well as at high strains. Please remember soils compacted on the lower side of on the dry side of optimum have less pore pressure than soils compacted on the wet side of optimum because the soils which are compacted on the wet side of optimum, all the pores are filled with water, hence the pore water pressure will be more. The soil which is on the dry side of optimum, uh, the, the voids are not completely filled with water, hence pore water pressure will be less. The next point is influence of compaction on stress strain characteristics. Now, a sample which is compacted on the dry side of the optimum will have a steeper stress strain curve. Hence, it will have higher modulus of elasticity compared to the soil sample which is compacted on the wet side of optimum. You have drawn stress strain curves in your BMT lab. Okay. The slope of the stress strain curve will give us modulus of elasticity. Okay. Higher modulus of elasticity means stronger the material. So uh, the soil which is compacted on dry side of the optimum will have higher modulus of elasticity compared to soil which is compacted on the wet side of the optimum, as shown by this graph or figure. Uh, the next point, influence of compaction on swelling and shrinking aspect. Okay. Now, the soil which is compacted on the dry side will swell more than the soil which is compacted on the wet side. Please, you can see in this table, soil which is compacted on the dry side will swell more. It will swell more because you add water and for soils such as clay, if you initially add water, there is separation of particles because of adsorption of water, or maybe because in case of sand it will be because of bulking of sand. So on the dry side, if the soil is compacted on the dry side of the OMC, it will swell more, and if the soil is compacted on the wet side of the OMC, It will swell less, but it will shrink more. The soil which is compacted on the wet side, it is going to shrink more and swell less. So please remember this. Uh, Soil compacted on the dry side will have flocculated structure if it is clay, single grained structure if it is coarse grained soil. And soil compacted on the wet side will have dispersed structure. And soil compacted on the dry side will have more permeability compared to soil compacted on the wet side. Soil compacted on the dry side will be more compressible in high pressure range, but compacted on the wet side will be more compressible at low pressure range. Soil compacted on the dry side of the OMC will swell more. Soil compacted on the wet side of the OMC will shrink more. Soil compacted on the dry side of the OMC will have higher strength compared to soil compacted on the wet side of the OMC, which will have lesser strength. So these are the effects of compaction on the soil. So